Space is vast. It's filled with billions upon billions of galaxies. These galaxies are not just randomly scattered. They clump together in groups like cosmic cities of light. Some galaxies are small and faint like dwarf galaxies. Others are huge and bright, containing trillions of stars. Imagine our own Milky Way. It's a giant spiral galaxy, a grand design about 100,000 light-years across. But even the Milky Way is dwarfed by some of the giants lurking in the universe. Let's start small, cosmically speaking. Dwarf galaxies are the most common type of galaxy in the universe. These galaxies can be as small as a few hundred light-years across. They might contain only a few thousand stars. That's tiny compared to the Milky Way's estimated 200 billion stars. But don't let their size fool you. Dwarf galaxies are important. They were some of the first galaxies to form after the Big Bang. Spiral galaxies, like our Milky Way, are known for their majestic spiral arms. These arms are not just beautiful to look at, they are dynamic regions where new stars are born. The spiral structure is maintained by density waves that move through the disk of the galaxy, compressing gas and triggering star formation. These arms are filled with gas, dust, and young hot stars. The bright blue stars that form in these regions are short-lived, burning brightly before ending their lives in spectacular supernovae. This constant cycle of star birth and death keeps the spiral arms vibrant and full of activity. Elliptical galaxies, on the other hand, are smoother and more rounded. They lack the distinct structure of spiral galaxies and are often more uniform in appearance. This is because elliptical galaxies have little to no star formation occurring within them. They contain mostly older stars and less gas and dust. The stars in elliptical galaxies are typically older, redder, and cooler than those in spiral galaxies. Without the raw materials for new star formation, these galaxies have a more settled, tranquil appearance. Both spiral and elliptical galaxies can vary greatly in size. From small dwarf galaxies to massive giants, the size range is vast. This diversity in size affects their gravitational pull, star formation rates, and overall structure. Some spiral galaxies are only a few thousand light-years across. These smaller galaxies may have fewer stars and less complex structures, but they are still fascinating objects of study. Others, like our Milky Way, can be over 100,000 light-years across. The Milky Way is a grand spiral galaxy with a central bulge, a disk filled with stars, and spiral arms that extend far into space. Elliptical galaxies can be even larger. Some of the largest known galaxies in the universe are ellipticals, stretching hundreds of thousands of light-years across. These massive galaxies often reside in the centers of galaxy clusters, dominating their surroundings with their sheer size and mass. Now let's meet the king of the cosmic jungle, IC 1101. This galaxy is not just any ordinary galaxy, it is the reigning giant of the cosmos, a true behemoth in every sense of the word. This colossal elliptical galaxy is the largest known galaxy in the observable universe. Its sheer size dwarfs anything we can imagine, making it a subject of fascination and awe for astronomers and space enthusiasts alike. IC 1101 is a mind-boggling 5.5 million light-years across. To give you a sense of scale, our own Milky Way galaxy is about 100,000 light-years in diameter, making IC 1101 over 50 times larger. To put that into perspective, if you could travel at the speed of light, it would take you 5.5 million years to cross this galaxy. Imagine the vastness of space you'd traverse, encountering countless stars and celestial wonders along the way. IC 1101 is not only huge, but it's also incredibly bright. Its luminosity is so intense that it can be seen from billions of light-years away, a beacon in the dark expanse of the universe. It shines with the light of over 100 trillion stars. Each of these stars contributes to the galaxy's overall brilliance, making it one of the most luminous objects in the cosmos. This galaxy is so massive, it's even pulling in and swallowing smaller galaxies. Over billions of years, IC 1101 has grown by merging with other galaxies, a process that continues to this day, adding to its already colossal size and mass. Galaxies are not randomly scattered throughout the universe. Instead, they follow a fascinating and intricate pattern. They are organized into groups called galaxy clusters. These clusters are like cosmic cities, bustling with activity and interactions. These clusters can contain hundreds or even thousands of galaxies, all bound together by gravity. The gravitational pull within these clusters is so strong that it keeps the galaxies from drifting apart. Our own Milky Way is part of a small group of galaxies called the Local Group. This group includes our neighboring galaxies like Andromeda and the Triangulum Galaxy. But even galaxy clusters are not the end of the story. They are just one part of a much larger structure. These clusters themselves are connected in a vast network of filaments and voids, known as the cosmic web. This web is like the skeleton of the universe, providing a framework for the distribution of galaxies. This web stretches across the entire observable universe. It is a testament to the grand scale and complexity of the cosmos, showing us how interconnected everything truly is.